Hello everybody, welcome to another stream. How we doing? So, last stream, we got our occluders and occlusion buffer working. So we now have a rough, here we go. So here's our occlusion buffer, it's the red part of the screen. It's being rendered on the screen. Here this black void is where the sphere is, it's inside this box, but it's currently disabled. But what we can do actually is get that both of them showing. Maybe we say only if the value, if not is inf. If we try that, we only write out a pixel if there is a non-infinite value. So we just debug rendering it in the sphere ray tracer. We simply just where we usually write the pixel out for where the sphere has been ray traced, I just debug the texture here manually. So this is the occlusion texture. Oh. What value would be in the buffer then? Just a really far one? Let's do less than 10,000. Okay, I don't know what's in the depth buffer then. Okay. Anyway, we can just disable the code this way then. So what is here? Here we go. Is all these spheres that make a sphere. So this sphere is made out of spheres. And what we have is a buffer now, which has a rough idea of what it roughly says what is the depth for this sphere. So we render some occluders, some axis line bounding boxes. So I think I have a debug render for that. So here's the depth that we get back, and there should be the occluders where we can debug it, I think. Is this it? Yeah. So here are the occluders. Oh, okay. So this yellow box and this yellow box, this is an instance, this one here, and we're seeing the occluders, how they produce a depth in the occlusion buffer here. Whereas this one, what we're seeing is all of the occluders, the bounding boxes for those. So the occluders are a rough version of the we basically find a cluster that's fully, we go down the tree of LODs and we find a cluster that's completely filled with spheres, and we make that an occluder, and then we stop processing the children. This also changes every frame because I couldn't sort on my sorting function. I decided to brute force it, but then it's been more complicated than I initially hoped. So in today's stream, what I want to do is I want to do another approach where I want to take the depth buffer from the previous frame and I want to use that as the occlusion buffer, because that's going to be our best case of something being occluded, and I want to see if that strategy is something we can actually use as well. So I first want to do that and plug it in, see what is the best case for an occlusion buffer. Basically, if we can get a near perfect occlusion buffer, basically. We're still going to have to keep this occluders thing if we go with this strategy. Because if you have something that pops up on the screen for the first frame, it's not going to have any occluders and it will have a bit of a lag spike. Or the frame will spike in time. So what we want, we'll need to have a rough bit section, we'll need to have these rough occluders be rendered as well. So let's get that, right, let's disable all of this stuff that we just got here. So we're not going to view this occlusion, yeah, we'll view the occlusion texture. So the plan is, right, we need to probably double buffer the depth buffer. So where's the depth buffer? Depth texture, that's what we call it. So we wanted 2 depth textures. Wait, no. We only need the one. We just need to make a new shader. And this new shader is going to be, it's going to basically copy. Oh, where's something with the occlusion? Occlusion something, that's what I want to find. Occluders. Make occluders. No. Render occluders. Ray trace occluders. It's something like that. Occluders ray tracer. Okay. So if we put our shader next to this one, so it's at least somewhat ordered. Okay, just above where we were. Classic. So this is going to be called populate. Okay, reproject. So the plan is, right, we're going to take the depth buffer from the previous frame, and if the camera moves as well, it needs to be reprojected, but also if the objects move, we probably want to reproject that as well. So I think we'll just call it like reproject depth buffer as occlusion buffer. And we're just going to do a straight copy, just because it's the easiest thing to do, but it will produce some visual artifacts though. And this would probably be pretty easy to plug in, which would be great. So occlusion texture. We also want the depth texture as well. Right. So I forgot what we called it again. Oh, occlusion texture. Reproject depth as occlusion, we should just call it that. Depth as occlusion. Reproject depth as occlusion. Okay. So for now, we're just going to do basically a mem copy, but for a texture. So it is essentially just going to be, oh, wait a minute. Read only, yep, okay. So we need to do a load texture 2D F32. Bundle constants depth texture SV dispatch index.xy. Get a bit of swizzling in there, look at that. Yeah, we also need to do the thing where we go, hey, is any of these and wait, less than, oh, greater than or equal the GFX global screen dims. Yes, I'll do it. So if our if this goes out bounds on the screen texture, then return. So that's only the ones at the end, right? Because you're dispatching in groups of 8 by 8 pixels. So the last thread group or dispatch group as we call it will be out of bounds, or some of the pixels will be out of bounds within that group. So you get the pixel or the depth value. Now we might have some depth bias. I do not know about this just yet. And there's going to be reprojection eventually at some point, but that will come later. This is a U32, and then we store in SV dispatch index.xy, and then we do bits from U32, sorry, F32 for a float, and voila. So then it obviously needs to write to do reprojection from old view to new view, and so you could probably have an understand kind of think how we might do that, and then the other one is also maybe have motion vectors to predict where an object might be. Might go. Because if you ever move an object and you reproject the depth buffer from the previous frame, that moving object is the depth is gonna be maybe moved along a pixel or two. So you need to account for that too. Hey there, collector of stuff. Welcome, welcome. How's it going? Right, so that's a simple shader just to kick off. Do you want to kick that off at the start of the right, so this is where we do the occlusion, where we build up the occlusion buffer. So this clears every MIP. So what we want to do instead, so we don't want to clear the first MIP, so we skip the first one. Then we want to kick this boy off. I might bust open my code. Oh, I've already done it. Super refreshing. Also just spilled it all over me at the same time. So, oh, where's that going? Right, reproject depth as occlusion. Then we need to do it across for the entire screen dimensions, and guess what? That's all still hard coded. So the GPU system is completely okay with stuff resizing. Just in my graphics system where we do all the higher level graphics, what I decided to do is keep it hard coded for some reason. So, yay. So I'll get fixed at some point. Right now I just want to find our graphics art style first. So if we look at that, it's nearly that. So reproject, project, depth as occlusion, depth texture, depth texture ID, and then the occlusion texture ID. Fantastic. So you need to make sure they're synchronized. You're writing to the occlusion texture, and then you are reading from the depth texture. Now, it's got to be careful there's no clear on the depth texture anywhere, so it's not pulling it from the previous frame. Okay, it should be it. So we should be populating there now a we should be taking the depth buffer from the previous frame and then populating it as the occlusion texture. So this is probably going to be this is probably going to need some slight adjustment, like some offset, but let's just view it, because I don't know if you want a perfect depth buffer, but you want one that's kind of close as you can get. Yeah. I mean, what value was we putting in the depth buffer before? Or in the occlusion buffer before? Hold on a minute. What's that clear doing? Clear. Occlusion clear. Oh, storing U32 max in there. It wasn't storing infinity. Right, so U32 max. So infinity just sets the higher bits, doesn't it? Yeah, you set the high bits. Let's do a bits from float 32, and we'll do as infinity. And we'll do that. All right. Hey, not so red. Doing good, man. Doing good. Just trying to get my occlusion buffer sorted out. So you're using the depth buffer from the previous frame. This is what we're visualizing now. So yeah, yeah. So last stream we got some occluders. Should I debug show that? So I'll show you again. Yeah, last stream I spent too much time on brute forcing a sort function without bringing one into the code base or doing a proper one. And it turns out I spent a lot more time on it than I wanted. And it might have been quicker just to grab the one from AMD, which I linked on the Discord. But yeah, anyway, so we got these occluders being ray traced, which was still good. So I'm happy with that. So this is the debug render of all the occluders. We're gonna see that, but it's not the best. So these two yellow boxes so this yellow box is an instance with the sphere in it. This yellow box is the just when you construct the volume on the GPU, and it goes down the LOD tree and picks the biggest occluders, or the biggest clusters with the fullest spheres, and makes them occluders. Yeah, so we got all this working last time. We were populating the occlusion buffer with a rough depth. But the biggest problem is yeah, did you make it work? I haven't plugged in the code which tests if something is occluded or not yet. That's what we're about to do. So if we go and see, if we disable what we've just made now, what you'll see is the red that, oh, what the crap is going on now? Oh, I didn't clear the texture. Okay, so what we should be seeing now, there we go. So these sort of dark splotches here are the occluders inside that sphere. And as you can tell, they sort of leave holes, but I don't know how good they are. We've still got to improve the occluder code though, because it just picks the clusters which are the fullest. maybe we can improve that. But we just essentially ray trace against a orientated bounding box to render these guys, and they're kind of cheap, but I don't know how it will scale. So what we're going to try and do now, so I still think we'll need this method when something just appears on the screen, just so we can sort of occlude something and not tank the frame rate. But I think if we're going to do this occlusion buffer method, the best thing to do is probably use the previous depth and then like reproject that. So if the camera moves or if the objects move, we sort of do a best guess and sort of maybe tweak it a little bit so it fails around the edges of the objects of yours, so you don't get any visual problems. So that's what we're gonna see now, is we're gonna measure the performance of, if we took the depth buffer from the previous frame, how good is it? Does it help us render things far quicker? And if it does, then I think we'll this could be the way that we render, but I'm not sure yet. I still got to compare it to a BVH tree again. But yeah, how's life been? Not so red. I'm gonna go and turn on my light. Okay. So now we've got our depth in the occlusion buffer from the previous frame. Let's get Milton out so we can describe what we're doing. So we have our occlusion texture is a 4-MIP chain. So it allows us to pick a pixel and check if we're occluded. So say if you have this cluster you're trying to render, it will get the screen bounds, and then it'll figure out what is my, when I, like, so there's a half resolution of this this texture. There's a 4-MIP chain, right, going down to probably 1 by 1 pixel, where based on the size of the object, we can figure out what is the appropriate MIP level to sample from. We take 1 pixel and we check the depth and see if this cluster is completely occluded. And if it is, we do not render it at all. So we're going to go ahead and write that code now so we can see how good the best case performance could be if we can leverage that previous frame depth buffer. I've written it in the past, but maybe I deleted it. I don't know. Prepare clusters for render. I don't have much going on either, just work. I'm back to working remotely this month. Cool. Excellent. Nice. Yeah, work from home is great. Well, for me, it's really good. I enjoy it. Helps me stay focused and not stress out as hard. Yeah. I'm glad to you still got to work from home after doing all of that placement stuff, all the getting introduced to the job. So where is it? Oh, here is occluded. So we need to make a function now. Let's just make one here. Um, so we need a way. Basically, we want to take the occlusion is occluded. So we need to have the read-only texture 2D of E32. This would be the occlusion MIPS base ID. So then we'll also need the what is the screen bounds, I guess, because we should already have calculated the screen bounds. So we essentially want like a probably a man, signed and unsigned, these things. Alright, let's just make it signed. Yeah, so essentially want like a, do you want like a top left? Or bottom left, sorry. Top right. Bottom left and then a top right, I reckon. Yeah, we could do it, then it's just more readable this way. So, yeah. So we kind of wrote this code kind of earlier. I guess in the occluder's ray tracer. So we kind of did it here. So we got the screen bounds and we calculated the MIP somewhat based on this. This seems to have worked. So let's take that code. It's got to be changed a bit though. Then this is the ray trace. Then you want to do something like this as well. But nothing to do with atomics. It's reading instead of writing. Right. So we want to calculate the width. Bottom left dot x, top right dot x. Wait, I did it the wrong way around. Damn it. Big takes small. Hey, Musco. Yeah, full time from home. For me. Yeah, so for me, I work full time from home. I also don't really go into the office much. We try to make me up like once every 2 months, but Christmas happened and we didn't really do it, and people on holiday, including me, and we didn't really meet up. But we're actually going to go. I'm actually going to go to the office, not this Wednesday, but the Wednesday after. So I get to see people again, which is cool. It's kind of like an hour and a half drive for me. So yeah, it's not something I would like to do every day. Put it that way. Me too. It takes a lot of time to get to the office. Yeah. Gotcha. I got to the office on Tuesday for me. That's not bad. Like 1 day a week is not bad. Yeah. Yeah, we do online meetings. So we do like a stand-up thing in the morning. We log our time, and then we basically just sit and chat for half an hour about things that we're working on or things that have popped up, or just like things that or news that we've read or whatever. And we do have other meetings as well. That happen. But yeah, we'll get along all right online. Everyone's quite productive online. I think what's quite funny is I actually got onboarded just after COVID when they started hiring again. I got onboarded when it was happening, and I remember I started and I sort of was learning the code base and just getting familiar with it, how to write shaders and how to, like looking at the the master library and all this stuff, just getting used to the code. And then my boss went on holiday after 2 weeks and gave me this task and wrote down basically five lines of what I need to do, and then I had a week to do it. And I did it. It was just great. But it's really interesting how people say onboarding people online is a no-go. And the only thing I have had as a downside to that is to not get to know people outside the team as you would in the office, which is a bit of a shame. So in my team, I know them very well. It's just outside the team, I've not had a chance to sort of mingle too much. Which, yeah. So, yeah, that's the only downside I've come across right now, really. And I guess that probably has some downstream downsides as well, because you haven't spoke with this person on the team. There's maybe not been these sort of conversations that have triggered from that, if you will. But yeah, it doesn't matter so much because I'm lower down. Yeah. So we're trying to calculate the MIP that we want to sample from our single pixel. Single pixel. So how are we gonna? So if you take your width and height, you're gonna take the smallest edge this time. Smallest dim. And you want to probably just log to that, I think. So this means if you've got 0. Oh yeah, what happens if it's 0? Oh yeah, so this returns Boolean. If smallest dim equals 0, then return. And I think they've probably got the same problem. Damn it. In this code here, our biggest dim, right. If biggest dim right. So back to here now. So if you're 0, it's going to return something, or it's going to return early. So if you've got 1, you'll get back MIP 0, right? Because the most significant bit would be set would be index 0. Then if it's 2 or 3, you will get MIP 1. And you'll grab a pixel. So MIP 1 will be half the resolution. And so that sounds about right. Then if it's 4, 5, 6, or 7, you'll get MIP 3, which is 4 times less. So that seems sensible. So after we've selected the MIP, we then downsample the coordinates. I'll do this thing again. Screen dim at MIP. Yep. Get the occlusion texture by offsetting from this base ID. Get the occlusion texture, and then what is this? Yeah, we flip the coordinate because we do bottom left origin instead of top left, and anything to do with texture intrinsics is always top left. Yeah. Wait, It depends how we store it initially, right? I forget these things. Yeah, don't talk to people outside the dev time for the whole month. Oh, you didn't speak to them for the whole month. Think how much opportunity to chat if we're not in the office. Yeah, exactly. Yeah, they used to do these things where you can sort of chat to these random sort of like everyone joins a Teams meeting and they'll just like split you into groups magically, like random groups. I did a few of those, but sometimes I just end up with people in my team. And sometimes it'll just be 3 people, so I just kind of just stopped going. Plus, because I also wanted to just get work done as well. I had that sort of feeling behind it too. Right, I messed up the coord. Well, sorry, I didn't mess it up. I missed copying it. That's what I meant to say. Right, coord is equal to screen bounds. So be bottom left. Bottom left. Plus dispatch index. Right. We just want a pixel. We just need then to use bottom left. So why do we need width and height again? We don't. So we just need to bring that down. And voila. So that would get us the depth, right? You gotta do bits to F32 to reinterpret cast it from a U32. And we need to pass in a depth now. So in goes the depth value. So this would be known as probably object depth, then occlusion depth. And then we just say if return if object depth is closer, less than or equal to, I guess, occlusion depth. So this is our function now that we can use to test if we are occluded or not. So here's our prepare cluster surrender. So the way this function works is it's dispatched from the CPU as many times as we have LODs. So it goes down LOD 0, which is the lowest LOD, lowest resolution LOD, then LOD 1, does all them from LOD 1s, and then does all the ones with LOD 2s. And it will only populate the LOD 1s if the LOD 0 has passed. So if the LOD 0 is occluded, it doesn't, for the volume instance, it doesn't emit any more of those because it returns early. And at the end of the shader here, it says if it has children and it's failed to render. So here's where it goes to render it, or yeah, adds it to the render buffer. here it will go over all the children and say, hey, go onto that process ring buffer, and next time this dispatch is called, it's our turn, and this will be the LOD which is higher to you, the higher LOD. So here we get a chance to plug in our lovely occlusion thing, is occluded. So I think I gotta plug in the occlusion texture base MIP thing, right? Excuse me. So, crap. This one. Oh, come on. Right, read only. So let's make sure we actually populate that, because it's easy to forget that and then the GPU will crash. So while we're here, let's just remember. Okay. Here's one I made earlier. So we get the resource index and put it on there. Now to synchronize on it, read only. Okay. So that is all good. What I would need to do now is call the function correctly. So we pass in that occlusion MIP base ID. Then we need to pass in the screen bounds .xy, which is the bottom left. Screen bound. Wait, I've already written it out as individual things. Let me bottom left, top right. Yep. Then I need an object depth. So we need a best case guess. So the best case guess would be what exactly? Right. So this gets in local space, damn it. Can I get it to get me the depth as well? Because the problem is the depth is kind of calculated in here. So it's whatever the here. Is that half dim Z in V space plus the sort of you bugger. What other thing uses this? And functions are the worst. The occluder ray tracer also uses it. It's kind of nice though. So let's make it return a depth value as well. So I'm gonna make a strut because I don't have out parameters. So screen bounds and depth. Wonderful name. Anytime you can and in the name, it's wonderful. Not. So yeah, we'll do the whole bottom left. Top right thing. Then we'll do a float of depth. Then we'll just pull them out like this. Right, that ought to be good enough. Right, top right dot x, bottom left, and recalculate that down here from the screen bounds. Right, I don't need this debug code anymore. I can actually go. Cool. So just looking at debug code as well. Bottom left. All right. So I think we're getting close now. This now needs to return a depth. So let's get this thing ready. Wait, why is the NF version? Right. It's fine. Let's just call it R. Bottom left. Then top right. Then the depth value, which you still need to calculate. And then we will return VR. Right. So how do we calculate depth? Like, what is this? So this takes a center position, local space, and half dimensions in local space with a transform to get it into view space. All of this basically produces a this takes the axis vectors in local space of the object, right? Moves them into view space. So in local space, they're obviously pointing perfectly axis aligned, right? Like that. And then you apply the transform, and then they end up like this in view space, right? Then this recomputes the half dim in view space. So it allows us to produce an axis line bounding box that is perfectly around the box. But obviously we lose, it ends up being bigger because it's including a rotated box. But it's axis line in view space now. So with this information, we can take the half dim Z and wait a minute. Yeah, which is the closest? You probably want to get this point here. Yeah, that's quite easy to do. So based on, so we already have maths to do this code. Yeah, we can do this. It's quite easy. But yeah, so from the origin of view space towards the center of the object, based on the sign of this vector that we've just drawn, we know which corner to select. So in this case, it would be the lower right. And in this case, it would be the lower left, right of the box. In this case, it would be the top left. And then that's the one we want to do a length op on and get a distance, I think. Yeah, that'll give you a depth value. And that'll be the closest point. I think that should be alright. So we already do that code down here. It's this code. Center position in view space. Wait, where's that sign come from? Yeah, center position in view space. That's the vector we just drew. Then we'd get the sign. So based on the sign, we can calculate that point. And then we can take the Z, and that's the depth. So, wait, no, we take... Or do we draw a vector? Wait. Wait, do we take a length up, or... Yeah, we take a length up. Yeah. Right, I think what I'm encoding into my depth buffer might be wrong then, thinking about it. We just take the Z. Right. Yeah, I think I've just thought of something that's wrong. So the value that we actually want is the depth of the object. Do we? Or do we want the depth along the ray? Because right now what I do, if we take a view, here's the texture, here's an object, and let's say, maybe we say here's an object. We take the depth at the moment and put in the depth buffer, the length along the ray until you hit the object. Is that the same? Is that the same? No matter what pixel, like, as saying, getting the Z value. Yeah, it must be. Yeah, it must be the same. No. No. Yeah, because as you go further and further to the left, the longer the ray will actually get in length. So basically, the depth that I don't know what depth we want to record. Yeah, you want to record the depth in view space and not the depth along the ray. So that's actually easier to calculate in this aspect, but I need to make sure when we do the ray trace that we calculate the correct depth and store that in the texture. Wait a minute. Something about doing the reprojection thing. Hey there, Katsumoy. Is frosting culling as a performance optimization for a game in the style of Trine 4/5. It is a side scroller where you can only move to left and right, but it uses purely 3D models. So I've seen previous Trines. Let me take a look. I guess it's the same. where it's just, yeah, as you're saying, a side-scrolling game. Like, you're still gonna need thrust some culling because it's 3D, and you're gonna have objects which are partly on the screen, partly off the screen. So there's multiple levels of thrust and culling. But yeah, you're not gonna be like. So if you take this sort of top-down view thing, right, you might say you're on a side-scrolling game where you got the player running along here, right? And it's got a gun. I mean, I don't know, or a sword. I don't know. That's probably really bad. It's just got hands. And maybe a smiley face, or maybe a mean face and a hat. There we go. Maybe not the hat, hasn't look good. So basically, here's here the main player. You've also got to render the rest of the objects. Now you can do a system where you're like, hey, the player's in this zone, so only render the stuff that's in the zone. Like maybe it's like a grid-based system or something like that, but it's like only has to be like a 2D a 1D grid or whatever, right? What zone do they fall in? Therefore, only render that. Or what zone is the camera in? Therefore, only render the stuff within the zone. But you're still going to have problems where the camera doesn't quite. It may overlap multiple zones, and it may overlap just one zone, for instance. This is just a case, sort of. So you could have an object which is maybe another enemy, or an enemy, because it's the only enemy I've drawn at the moment. And he is off the screen. So you still want to thrust and cull this guy, right? And this system, with this grid system I've just mentioned, is a way of thrust and culling as well. But yeah, you're still going to want to thrust and cull each object against it as well. This is doing multiple objects at a single time by putting in a grid. This may not work in every game, but in this particular game it probably would. And then you can even go even more in depth where you might have a player that's half on the screen, and maybe, just maybe, your system is complicated enough and has where maybe these are different meshes or different clusters or whatever, and maybe these clusters could be culled and it doesn't have to render these because they're off the screen, right? But these clusters will get rendered, right? So yeah, thrust and culling is needed in 3D perspective games. Yeah. So I'm trying to think about the reprojection code now, because if my depth buffer doesn't store the depth along the ray, it stores the depth in view space. How do I reconstruct the point out in view space of where the hit is? No, maybe the depth along the ray is not a problem, as long as it's consistent. Yeah, let's do the depth along the ray. It's consistent that way. Right. So how we construct that is we need to get the point. The nearest point. What is the nearest point? So sine negative x sine negative right, I need a new one. I need the nearest point. Nearest point negative x negative y sine So again, it would be this point on the bounding box, view space bounding box, on that side, and on this side it'd be this one. Right. So we take the length of that, and that's our depth. Alright. So we poke that out. There you go. Voila. So now we're nearly there. Right, it says read write. It's an invalid cast there. What's going on? Oh, we didn't fully put the thing in. Right, depth. Yes. Excellent. So do we want to call it depth? The depth is probably not a good name. Thinking about it, let's probably correct that. Oh, you know, let's just call it depth. Screw it. Right, it's just the closest depth. No, I'm giving it a much better name. Closest depth. Okay, very nice. Closest depth, closest depth. Okay. Oh, crying out loud. Return can be called... Right, so got a compile error. What did I do to bugger that up? And also, shouldn't there be type checking on this sort of stuff? Ah. So my compiler doesn't check this. This isn't good. Should I go and fix that now? So, yeah, I can do that quick. So in the return statement, basically, statement return. Here, expr. Yeah, so I didn't do the check. So basically, ensure compatible assignment. No error. Yeah, we need a new error. We need a new error. So if the return data type is not void. I forgot what I did for void. Did I do 0 for void? I think so. Forget these things. AST basic void. Alright, we'll do this. Right. So if that is equal to void, or not equal to void, we want to return an error. I can't believe I've not had this error. Missing return expression. We probably want to point to the location of the function as well. So the other location would be ASTgen function identify location probably. Then we probably also want to pass in the type name of the object, of the return data type name. So we'll just poke that in there and get a new error in there, and then test that out. It should work. Type mismatch. You know, let's just do that. It's better. Okay, so I want to find where the error messages are. Excellent. So we want to say returning void, or like return it, missing return expression. On a function that expects this to be returned. So we try that out now. So we hit compile. So compile the compiler. Good. So let's do a new release build on that one. So we've got all the optimizations there, and it compiles nice and quick. Or compiles the shaders nice and quick. So we'll drop that in the third party. There you go. So it's in there now. So we hit F5 now in the game. Excellent. Here's the error we just ran. So missing return expression on function. Yeah, the lines are always, they're kind of usually off by one token, but that's all right. I don't mind this. But we get cool stuff like this. Originally defined here. Here, express Boolean, and bam, look at that. Voila. Isn't that amazing? So now we can close that. Goodbye, compiler. Right, so now we can say, so it's not occluded if it's just too small to even figure out. Wait a minute. Oh, it is too small. If this thing is too small to sample for, then it's too small. Yes. It's occluded. I see, so I'd imagine that should be enough. I'm modeling stuff in Blender. I'm thinking of loading big chunks of models the size of the screen, chain them together to create a level. Do you think this should be doable for graphics cards today? Really, all this I have is blend, fong, lighting, diffuse, and specular textures, and doing models in Blender. Probably also swapping each mesh in chunks. Yeah, so you should just implement as much as you need, right? So you populate your level with stuff, and if you start with, what days was it I do? Start with frustum culling whole objects, right? Frustum cull whole objects. You don't have to do at the cluster level if you don't have that. But just cluster cull, just frustum cull the frustum cull the mesh instances and see how well that does. And then if you need anything more, you can look into further optimizations, basically. Okay, so we're compiling now. Let's take this. Wait a minute. That's saying it is occluded. It's only occluded if the object depth is greater than the occlusion depth. Yes. Right, so let's plug this in. Should we see the thing in action now? So if we look for 48, that's where we did the temporary debugging stuff. Let's disable the debug view and let's run this thing and hopefully it doesn't crash the GPU. Right, here we go. Right, now we're running. It's running blazingly fast in comparison to what it was. And we're getting some, see the depth buffer is probably so good that it's occlusion culling too well, basically. So what I want to do is we probably want to add some form of like bias or whatever when we do the reprojection step. Where we take away like, so when we reproject the depth buffer from the previous frame, let's add a bias. And let's do 0.1. So that makes it get closer. We're going to make it go further away. So it's a plus. So let's try that. Something really weird going on. As you can tell, you can see the clusters sort of around here-ish. Oh, they're 4x4x4 set of spheres. So I think, wait a minute, do I want the closest depth? Wait. Yeah, I want the closest depth and I probably want, okay, let's add a bigger bias. Let's add like 1. Probably is a, is it occlusion culling? I wonder what it's culling at that point, right? So should we keep note of like what got called? Yeah, that's good. Yeah, let's keep a look at that. So is occluded. So should we now print out like, oh yeah, we occluded cluster index, blah 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 blah, right? So looking at performance, it did look quite good. But let's still remain skeptical. Again, this is best case scenario. Cluster instance. Like, I don't know how good this can scale when we have tons of stuff and moving stuff. So that's definitely something we need to invest more time in. Right, so what is that, right? What is that? Is that culling cluster 240? Just 240. So where are the rest? Oh, is 240 the root node? I don't know. It should be bump at or yeah, LOD 0 should be done first. What is? Is the depth text used anywhere else? Scene depth to do a right. We just store the closest hit depth. We don't read from it. Okay, so if I don't say if I populate it with a depth of infinity, right? Does that change our problem? Does it change our problem? Right, we're still getting a bit of an issue here. Okay, so it's nothing to do with the depth, the occlusion buffer anymore. It's probably an issue with... Yeah, so here it is rendering. I've disabled occlusion. But why is it stopping it? Oh, what LOD is that? LOD blah, right. Cluster LOD. Alright, LOD 0 apparently. Why is that at 240 though? I thought that'd be the first one to be allocated, but anyway. So it's occlusion culling. It really occlusion culls. Oh my days. I'm an idiot. Here's the problem. We're rendering our object here. Here it is, with the sphere in the middle. So we go, hey, give me a vector to the middle, right, of the object, and we use the sign of that to calculate the point. So I'll be using that thing here, drawing a line to it, taking the depth. That depth is obviously behind. We need to, because we're inside the object along the X and Y, we need to just shoot the ray forward, and that'll be the closest. So that's our problem. And that will be, how do you know how do we solve that problem here again? Like, what did I do to solve that problem again? Let me turn on these debug renders because I'm confused. We only really want to do this if we're the first one to do it. How can I... Half dims local space, what is that going to be equal to? 64, isn't it? Yeah, so if only... Oh yeah, if that is just .x is equal to 64, then we know it's the root cluster. Oh, come. Huh? Half dims in local space. Right, actually it probably is like a 0.0. Um 0.5. Wait, no, half dim. 1, because it's in sine norm. There you go. Right, so getting our view space bounding box being rendered. Okay. So how do we solve the problem here again where it selects the correct things to move into space? Oh, because it moves multiple and it just takes the min-max of all of those. I see. It's got a bit of redundancy. See these points here? It takes these points and then moves them into screen space to produce the green screen space bounding box. Yeah, and as I was saying, when it's at the top right, it takes that bottom left one at the back. And when it's here, it takes the bottom right at the back. And it flips the things at the near. But yeah, for us, we want to take the bottom left at the near, because that'd be the closest point in this case. But when we're in the middle, we want to just do a ray straight forward. So in that case, nearest point in view space, this is an if statement. So we're saying if the x and y, where is it? In view space dot xy less than equal half dims. Am I looking at doing something like a we're only on the xy coordinates, and we want all of them, every, but like, what am I, do I want the absolute? Yeah, I want ABS. ABS F32 times 2. Right, so we can use that to tell whether we just want to use the center position in view space, and you want to do you would rather just hit the box. So it's probably just center position of view space dot x. Sorry, dot z I meant. So 0, 0 in the x and y. Dot z, then take away the half dim view space. And that will get you that, and then you can just do the length. That's kind of just silly. You can already do the depth this way. So closest depth is just that. There we go. Cool. So that will then mean that our closest depth will now be actually correct, I reckon. Oh, what did I do now? Enough parameters expected 2, you got 1. Okay. Try that. It even fails outside the box. We could draw a vector towards it, right? In view space. Let me try something. We'll call it BBBB. So we got that draw debugging stuff, which is super nice. Draw 3D. We're going to draw from in view space from 0, which would be the center of the screen, to this BBBBB thing. I forget the rest of the parameters. Thickness, color, thickness of 6. Color then Z test, do false. Alright. The problem is I'm looking directly down it, which is really annoying. It's in front of my face. So I think we should probably just make it, let's put it out into the world maybe by about 5. Maybe it will obstruct us a bit, I don't know. Yeah. It's really big. But we can tell it's staying in the middle, right? This is meant to be a vector, but it's just so big in front of our face. So we are seeing it is going straight forward and hitting that. Then it really just goes to the bottom left in that case. You know, let's make it a bit thinner, and maybe let's move it out a bit. Let's move it out by about 20 instead and make it like 1. Right. So as you can tell, it does go to the lower left. I've just increased it by 20, so it's not hitting the front lower left. Yeah, then it goes to that one there, which is good. That's what we wanted. Then here it just goes straight forward. Right, when you're inside the here, it just goes straight forward. Right, so that's correct, right? That is 100% correct, the logic. So for some reason now the view, at the depth that it's using, that it's comparing against is a bit off, and I don't know why. So why is that? These are correct. Let's take a look at the depth that we saw in the depth texture. So in the depth texture, what we store is the closest hit depth, and it's the closest hit along the ray. Yes, the closest hit along the ray, we store it in there. And then we've got that reproject step, which is not even reprojecting. It's just a stand-in. And we're taking the flip 32, reinterpret casting into a U32. Okay. And poke it in the occlusion texture. It is running through that downsampler though. So maybe the downsample code. Right. I think I can see what's maybe going wrong. So when it's finding a MIP to read it from, I think the problem now is that the MIP texture, the way it's downsampling is not quite correct. So let's check the propagate code. So this propagates between the oh no. I don't understand why. So we could compare the two depths maybe. Or should we force it to only read from... Let's force it to only read from MIP 0. That's a good test. Is occluded. So we force it to only read from MIP 0. That's... that will make it always pass though. But we make it... let's try this. Let's instead make it MIP 0 and then increment that to be half of width. So it's going to grab it from the center of the cluster, or of the center of the cluster rather than the bottom left of the cluster. And that would be a good test when it's testing the clusters. Right, let's try that. Right, so it's passing. Oh, it's not even passing. Okay, the center of the cluster is off the screen there. That's why that failed. So it seems like LOD 0 is now not being polled, right? It's now the problem is the other LODs. So that's probably a bias problem. If I correct that, let's do 1 or something, I don't know. Bias of 1. They kind of jump a bit as well, which is really weird. Like, yeah. As we move back, it's got a bit of a problem. That's where the reprojecting is probably going to fix it. Move to the side as well. It's going to have a problem at the edges. See on the left, move left or right has a problem depending on which way I move. And that's because the depth buffer is not being reprojected yet. Which is fine. So there's still issues when something is still there. But yeah, so I think the way either propagating. So it seems like the problem comes from we're fetching our I might debug render this stuff a bit. What am I trying to do? So the current problem is we have an occlusion texture that we're taking from that we're populating with the depth buffer from the previous frame, and it doesn't quite, it's occluding stuff too well. And so our thing is not rendering properly, basically. So it doesn't render at all here, which is weird. But so the depth value that it gets back is too close. I need to figure out why. It's occluded if the object depth is bigger than the occlusion depth. So I think it's the different MIPS. We can possibly debug render those and flip between them. Yeah, it might be wise to do that. So we could do a time-based thing, and we can make it wrap. I don't know how many occlusion textures we've got, but let's. So you got your U chord. Let's display the depth texture instead now. And let's just display that for now. Oh. Are these occluders too good and they're causing... Are these occluders causing my... So the occluders that we made last stream, are those causing it not to render? And then sometimes these things not to render? Oh. Okay. Let's not fill in occluder ray tracer. Where's that? We're going to disable that for now. And let's just see what it does without that. Right, it's still the same problem. So it is the depth buffer that is the issue. Let's only use the reproject. Let's only use the occluders and see how well that does. Oh, that doesn't clear the texture initially. Right. Oh, so the occluders still cause a bit of a problem. Let's not write anything into there except for the clear function. Let's see what happens there. Let's disable the... Let's not write the occluders in there into the occlusion texture either. And let's just see if it renders it all. No, there's still problems here as well. What is happening? Why are we getting... So we view the occlusion texture then. So I think my propagate code is incorrect when it propagates it between the MIP levels. Hey, render goblin. Wanna be it? Hey, you talking to me or render goblin? If you're talking about me, there's people who understand what stuff way more than me. Like, there's levels to it, man. There's levels. So reproject. Right. So let's look at the propagate code then. So this takes. So we write some occlusion into the occlusion texture at different MIP levels, and then we propagate it between all the MIP levels by downsampling it, then upsampling it through all of the MIPs, right? So that code is probably busted. I want to view the I want to view this occlusion texture here though. Right, it should all be red. And then this ball shows up. Why does that ball show up? And then it doesn't show up. So why does that ball even appear? Oh, it puts depth into the... Right, that's when it puts depth into the depth texture, and then the draw 3D does a depth test against it. Okay, so that's fine. So what I want to debug now is like this depth that I've got out of this here. Right. Man, I've got so many shaders now, my printing is just off the screen all the time. Maybe I need to wait. But, so I can print to debug. I could also get my UI system back up and running and just display stuff on the screen. So, yeah, the occlusion you should be pulling out should be like infinity or whatever, right? Right. Is occluded. So occlusion depth, H. Yeah, do I need a bigger screen to fill that text? Probably. Yeah, get a 4K screen and make it so no one else can view the. Look how many shaders I've got. Mostly because I just do all the 1 or 2 for every LOD, and I do it all the time. I could disable my cluster construction code, and then might just make it appear on the screen still. But yeah. I'm just looking with an open mouth what you're doing. My knowledge is ending. Simple to do programming C#. That's cool, man. You just keep at it. Keep asking questions and Google searching, and do that for 10 years, and you'll be like massively further than where you are now. No, I go on Windows. Like this game that we're in works on Windows and Linux, and I did do some Windows porting basically. Right, so here we're not seeing any occlusion depth. Well, any tanking and performance. Right, occlusion depth 0. 0? 0. Why are we getting back a 0? Is my coordinate out of bounds? Did I do an out of bounds sample or something? Holy moly. Load. From MIP. Size. Right, and then we got, so put all of that stuff in there. Coord.x, coord.y. MIP. Size. Screen dims at MIP. Y and X. You have 104 lines visible in Editor. I have half of that. A bit zoomed in as well. W3C scores is alright for web dev, I guess, but it's great that it's all free, right? Times three panes. Pretty decent, especially when we're working in C. And C++. Obviously you're not, but like header files and stuff are great for that. Or that'd be a great use case for that. Right, sample 0 and 1. Oh, for crying out loud. Out of bounds. What have you done? A MIP 9. So I think the problem is I didn't do a power of 2 texture size. So I've royally buggered myself up. So my occlusion texture probably needs to be rounded up to nearest power of 2. And then that will help. I think help a bit. Because basically when it's downsampling, it's probably missing edge pixels. So this occlusion texture. I think I've got an X power of 2 function. I gotta find this somewhere now. It's been a while. Int roundup power 2. There's my boy. So you probably just want to do that. Oh, I've not used these. Crying out loud. Copy pasted. Yeah, so if I round up those to the nearest power of 2, that's fine. But then you want this sort of screen dims at that. Where's that useful? Oh, it flips it. Right. Sure. That might be a bit off though. Main language used to be C++, fair play. But big 4K monitor is just useful for front end code. Was most useful for front end code. Also, layers of abstraction reacts. Oh, okay. Yeah. Don't know what to do now. That's gonna be. It's got to be round up to nearest power 2. So we probably want to encode a different thing in here and call it. I don't even have. Do I have a next power of 2? I remember EC7 pains to fit as much as possible for full stack when refactoring. Wow. That's crazy. Yeah, I never did React in web dev. I did a lot of jQuery and unfortunately PHP for a bit. But yeah, mainly just raw JavaScript as well. It was before that React was big, I did web dev. So I think I've got to store the MIP. Wait, what is it? The occlusion texture dims instead, which kind of sucks. And that way, core int roundup power 2. I think that's right. I think it works out right. Yeah, so we'll use this instead. So basically here, texture dims. We've got to do that same thing in right, let's try that out this time. I also want to try out I also want to fix in the ray tracer for the occluders. We also use the screen dims in here. Now that needs a similar treatment. We'll use the occluded texture dims instead. And then it'll be texture dims. Now the only issue though it's probably when you populate it with the stuff from the previous frame now, the different sizes. Maybe this was not the right idea to do it this way. Okay, maybe it's sampling out of bounds. Maybe this is correct. Have a think. Is occluded. Um, should it really be the bottom left that we're looking at? Yeah, it should. Oh, that's right. Then you probably want to clamp it within the range of. No, I think what we're doing is fine. Is correct. Okay, so let's hit. Right, let's try that out now. You can use tail and head to pick the range of lines. Oh, okay. That's not a bad idea. So I could just say tail minus. Right, that could work out. Yeah, it's probably a good idea. Pipe the result into tail. And I could do head as well to cap it, it's not bad. Yeah, it's probably 40 or something like that. Oh. Something wrong with my pipe? Oh, right, so it comes from a file descriptor, right. No, tail would be... Oh, tail dash F. Right, I see. Like that. Wait. Whoops. I don't know what I did there. Hmm. Yeah, I'm not sure what's going on. Right, so what do we see here? Right, so loads from 0 and 2, and now it's inside the texture, right? Which is good at least. But it's still getting a depth of 0 back. So if we look at the propagate code, propagate. So propagate is going. Where's it getting the? Okay, here's the problemo. We need to get this rounded up to the nearest power of 2. Why does it need a max source dims? Min max source dims. What the crap is that about? What? Uh. Mm. Oh, I see now. Just between those two vectors. Don't want to call it max though. Okay, so let's sort out this at least. Let's round up to nearest power of 2. Bit messy, but again, we can clean up this code later. Just more concerned about getting things working than how clean they are. No, the rest of the code base is clean, so I'm not fussed. So that should be corrected, hopefully. So let's see if the depth gets... Right, so still not seeing the... Ooh. So the occlusion depth is still 0 for some reason. So there's something wrong with the propagate code. And maybe doing this power of 2 thing was not needed, but I think it should be needed. Right, so let's read what's going on here with this propagate code. So first we propagate backwards from the highest MIP to the lowest MIP. Oh crap, I did the wrong damn code. Oh my days, this needs to get deleted. This is the one I've commented out. Goodbye to that. Okay. Right, that was the old occlusion code. So let's quickly do that again. Right, height. Just plug those boys in there. There we go. Okay, so hopefully this fixes it. Alright, it's still got issues. But let's look at the values. And it's still 0. Okay. So there's definitely something wrong with the propagate code. So propagate backwards fires first. So what does that do? So it takes a destination texture, which is right. It's the number of MIPS. So destination is smaller. Source is the highest MIP at the start, obviously, right? There's the highest to the lowest MIP. So we might be better off debug visualizing this, but yeah, I guess for now we'll just yeah, now I've increased the size of the texture, probably increased more bugs because it's not the same as the depth, the texture from the depth texture, is it? But we're only clearing the result to infinity, so we should be seeing like that's a different problem that will come later. So anywho, the destination dims are that shift right that, yes. Wait a minute. Propagate backwards. Sorry, from the lowest MIP. Yeah, the smallest resolution down to the highest resolution. Okay. So source is bigger. Right. Source is bigger. So this is an upsample. Okay. This max shouldn't be needed anymore. Because they're power 2s. try grep line buffered. What you want to see. Oh. Yeah, I'll give that a go in a minute. Let's just get this thing to search for the pattern. Right. Okay. Yeah, but sometimes I want to see other stuff as well, so the tail thing was interesting. I'm sure we can get that to work. Move that max thing, that was dumb. Okay, so this is a down sample. Oh, for crying out loud, I did another max thing here as well. Screw this thing. Oh wait, maybe we need it. Why is it saying subtract 1? So say if you've got like a, it's gonna be, right? Yeah, we shift right by 1 for the MIP, okay. But anyway, so you'd be able to go the way down to that's 10 MIP levels, isn't it? Yeah. It's 10 MIP levels. No, 11 MIP levels. 10 is your biggest shift. How many MIPs we got? Let's make sure that's right. Make sure that's right. I could have probably aborted that instead, but there you go. 11. Right. Yeah, so it's that take 1, that's correct, 'cause you do 2 at a time. Anything else I want to see? So let's view all the destination dims. Well, let's just view like to that. So BC destination dims.x, BC destination dims.y, BC destination dims or source dims.x. Let's try that out. Righty-o. So yeah, because it's not 1080, right? It's less than that. It's less than 1920 by 1080, so we're getting. It's doing that damn take 1, isn't it? Why is it doing that? Why am I doing a take 1 like a melon? Why did I do that? Why was I thinking that way? Must be incorrect. Right. So the values that we're seeing seem. This down sample, right? Down sample. Sorry, it's an up sample. So it goes from. Oh, it's actually the other way around. So yes, it goes from low to high, and it's exactly double, right? So no longer worry about odd numbers, which is good. So that's nice. Let's double check this one, and it should go the other way around. So it should go from high to low instead of low to high. Again, the arrow is it's meant to be the other way around. It's opposite day apparently. So we're going from high to low, high to low, high to low, and that is exactly half. Perfect. So, yeah, I'm happy with those numbers now. Let's double check the shaders before we continue. So this backwards, we should probably rename it because it's basically a upsample. And then we want to downsample. Okay. So what is next? I want to check the shader source code. So this is where we're going to write to. If it goes out of bounds, bail. Then we shift right to get the source coordinate. Min it with the source dims. We shouldn't need to do that anymore. But I guess it doesn't matter. It's probably free anyway. To do that. Safe as well. We load the depth from... Yeah, we load the depth from the current pixel and the depth from the pixel. Wait a minute, why is it one depth? Shoot. What the crap is going on? So each thread gets a pixel in destination. Oh, so multiple sources are read. So this source pixel is read multiple times. Okay. Take the min between those two and write it back out to the destination. Okay. That is fine. So downsample, you're going the other way around, right? So you do destination. We load from the destination. The source is the next MIP up. So we multiply it by 2. And then we grab, that's the base coordinate. We grab all of them in a 2 by 2. Then we max all of the guys. Right, we need to think about this min and max thing, and then we take the min of that. Right, okay, so let's think about, that seems correct to me now. So, but let's think about this min and max logic. So the min, if you've got a depth, so if you've recorded in a lower MIP, a rough depth value, yeah, you want to take the min there, okay? But yeah, but when you're downsampling to a lower resolution MIP, you want to take the depth which is furthest away and put that there. Okay, this seems like it makes sense. So let's run that one now. Hey Meatball One, how's it going? How you doing? Right, so hopefully that still works. Crying out loud. It still gives me a 0 back. Right, so we did solve some issues by the looks of it, but we're still getting a 0 back. Why? What have I done? So what about the clear? So the clears all the levels. Dims. Right, that dims has been buggered up. That dims now needs to be in the power of 2 thing. This could probably have been a variable, and but anyway, there we go. And no max crap. because we're a perfect power of 2 now, and this is the way. Let's give that a go. Alright, it's rendering, but not there. Crying out loud, what have I done? So load pixel 0, 2. Why is it loading at 2? That's out of bounds. Right, something's happening with these coordinates. When we're trying to sample our single pixel. Right, this is much better now it's rendering. This is good. It's just when the box gets bigger than the screen, so big that it uses such a low MIP, and it ends up going out of bounds or something like this. So like, okay. Right, so I think we've improved the code now. But it's just, you've still got this issue then. So if we take a look at that, what coordinates are we getting? 0 and 2 on the Y. So let's take a look at that sort of like is occluded. Oh yeah. So Y O Y. Is this bottom left leg out of bounds or something to the screen? Let's print out some more information. Right, let's all that or whatever and just do like a... let's just do another whole set of data as well. This time it's the pre-core, it's bottom left before we shifted it, which is not possible actually. Right, and then we'll just use the screen dims. O.x, O.y. And then we'll use graphics global screen dims.x. All of the print. Okay, so we run that. Crap. Did we oh damn it. I missed the format arg thing. Okay, so here's where there is an issue. Right, so the lower left is there and there. This is the size of the screen, obviously. Well within the bounds. And it shifted right 9. Something is wrong there. Because 9 is obviously greater than... shifting right, yeah, it's obviously that 250, yeah, it's 512, isn't it? So... why is that 2? Is there something wrong with my... oh, is that a negative value? It's sine, isn't it? You gotta clamp it, probably. Wait. If your bottom... right. First of all, you're shifting on a shifting on sine value. Let's print it out though. Wait, we should do a D, isn't it? It would show a big number if it was negative. So we did shift right MIP. Let's take a look at that value. And maybe let's cast it to a... Let's do shift right. Maybe there's something wrong with this thing here. This operator in the compiler. I don't know. Okay, that's when it went out of bounds. The Y went out of bounds there. Let's make sure it's all on the screen still. Right, that is 0. Like it should be. But if I do this with an equal on it, what is that? Oh shoot. Right, it turns out expressions as doing this here is apparently causing issues. But anywho, let's move this. Let's do O.Y shift right equal MIP, and let's see what that does. And if that produces that same thing, then it must be to do with the compiler in some way. No, okay, it still produces a 0. What did I do? Please. Right, 1, 2, 3, 4 MIP. Yep. Oh, it gets flipped on the Y, damn it, of course. Oh shoot, it gets flipped on the Y, doesn't it? I meant to take 1 on it or something. Yeah, I meant to do a take 1. So that's the reason why it's sampling out of bounds. So I think I got a lot of that code somewhere else where it does that. So I've got a bunch of off by 1 errors. Alright. Why is that's failing? Because it goes out of the screen. So what we need to do is we need to clamp this into the screen as well. So if it's less than the screen, you need to move it in. If it's greater than the screen, it's occluded, right? So if any of greater than bottom left greater than or equal to the screen dims, then that would then mean it is occluded. Then you want to make sure that you max. You then want to make sure that bottom left.x, or bottom left is just maxed in general with, it's not floaters, it's signed in, bottom left and a 0, right? Okay. Good. So I think that will mean we get a sensible value now. So let me just remove this extra print information that we put in. Maybe I should disable the printing, actually, because it's just going to spam a load of crap into the... you know, let's delete the line. I think that's fine. The problem is this is a damn unsigned in. For crying out loud. Signiness. So that's greater than or equal to or. Alright. So okay. So it should always be showing. It should not be occluded at all, but it is getting occluded still. Like we're literally got infinity in the buffer, and for some reason there are values that are coming back which are not infinity, and it's really weird. So let's bring back the print code at least. Let's delete those there, won't it? Tough, isn't it? Yeah. Been a bit of pain in the butt. Trying to get this thing to work perfectly. Oh, this is even just an empty occlusion buffer, and the testing is just... yeah, there's so many variables in there, it could just be wrong. You're trying to predetermine which polys are visible without rendering all of them. Yes, kind of. Yeah. So we're not using polys, but yeah, we're trying to occlusion culling clusters at the moment. I don't know what I want to do the spheres, but we're culling the clusters. So we've got a depth buffer basically where there's a pixel. Each pixel has a depth, and this will have a value where it's the closest depth that we can guarantee that is definitely there's something that's definitely there. But so we basically sample a pixel, so we get the size of the object. Maybe the object is this big. We find the appropriate MIP level where the object that's this big and the pixel it fits in. And then we sample that pixel and check the occlusion value, and if the occlusion depth is further away than our object's rough depth, then we can basically keep the objects. But if the object is behind the occlusion, we don't render it effectively. So it's like a bias towards some invisible ones are rendered. Yes. Because it's much preferable. Exactly. Yes, it's a rough guess because you don't want ones which are visible to just stop rendering, and because if not, you just get very glitch rendering. What you want is you want some of the invisible ones to render. Um, yeah. Exactly. Yeah. So we're going to try and use the depth buffer from the previous frame plus some big occluders for when new objects appear on the scene, basically. Um, but yeah, we haven't got any of that plugged in right now. I've just unplugged it because apparently the base clear value is not working. So I've cleared the screen to like infinity, and I'm plugged in the occlusion culling code, and it's it's deciding to, for some reason, not work. So I'm just trying to see what the sort of values we're getting. So this occlusion depth has been 0 for a while because we've been sampling outside the texture, but let's just hopefully get something different now. Which I've just been reminded, all these coordinate.ys are probably off by 1 as well and right outside of texture. So I'm going to just fix all of those. Off by 1 errors, my favorite. They're everywhere, clearly. Right, we're back. Okay, so these occluded codes, give that a go. You've just noticed that usually, but not always, the straightforward way is simple code, but the moment you try and make it faster, more optimized, the code explodes in complexity. Yeah. Yeah, so... Yeah, definitely so. Like, the simple code is often more malleable as well into becoming... By default, it has a degree of... It entirely depends what you're writing, right? If it's GPU code, it needs to be performance aware to get anything. You need to know exactly what goes on to really achieve. Yeah, I get. Yeah, for CPU code more, like the simpler the code is, usually it's kind of just. Mm, it's hard already because what is simple? You're you're looking at it from the perspective of just the code that you read is just less lines of code, like, or are you? Yeah, I don't know. It's hard to really answer that one because there's some code that you write that's really simple and it is just the fastest code. But yeah, if you're trying to highly optimize stuff, yeah, that applies. Alright, what the crap is happening there? We're getting some underflow. Right, it's not even rendering anything. It's just saying it is occluded. Um, I think we might have another problem as well. We go out of... So maybe I only want to print this if that is the case, right? If it's occluded print. So bottom left, if that's out of bounds. See, I don't know if we have a problem where if the object goes... You're trying to make, say, you get the smallest dimension. Maybe you need the max dimension instead. Get the longest dimension. Yeah. Better. Then use the largest dim to get the MIP. Probably better. Yeah, real weird problems like that still. So they're sampling inbounds and the texture's a bit buggered. Like why? Propagate. Right, it's because I'm doing mins as U32s. I should be doing a min as a float. Probably. Mins and maxes. I wonder what these values are. They should all be the same. It's not clearing the whole texture, is it? No, it is. If any are greater than, store infinity. No, let's do a reinterpret cast. There's no F peak. Yeah, it's F tail, isn't it? We're trying to get the we're trying to get the cursor position. That's cool. No worries. No F peak as in read the current character, but tell not to advance. Right, good point. Guess not. Because that all goes down to the kernel, right? Does the kernel have that? That's the first question. I don't think it does. But I guess the high levels could do seek back automatically. Yeah. Maybe. Let's try doing it this way. Bit from. Let's just reinterpret cast that. Right, so let's do the reinterpret cast here. And the other one as well. Wonder if this fixes it. Float. Float. Okay, then we do a bit from and poke that into the final point. Okay, so let's try that and see if that was the issue. Because I was doing min and max using ints instead of a float. Still getting problems here. Right. Now I want to get the, we shouldn't be having anything in the depth buffer. It's really, really weird. I don't know if that was the problem or not. So let's go and debug view the different MIP levels now. It should be infinity always. So color weather is inf, and it'll be red. So let's read. Okay, so all of those pixels are infinite. Now let's go up a MIP level. And then let's shift our coordinate. U_dot_x shift right. Right, so MIP equals 0. MIP U_dot_y shift right MIP. That's true though. Can the OS read from storage without mapping a down file to RAM? True. That's true, maybe. Yeah, mapping it. Yeah, just that's another way. Then just map the file. Yeah, it's quite good mapping the file. Let's try that out. So now I'm going to debug render MIP1. See how that looks. MIP1 apparently looks. Oh. No, that's fine. That's still fine. MIP1 is fine. Ignore the fact you can see the ball here. That's because the depth texture is being filled in and these debug shapes are being called. Sorry, or they're testing as the depth buffer. That's why you see a circle show up. That's fine. Right. Oh, is that? Oh, damn it, that's MIP 0 still. Right, MIP 1. This is MIP 1 now. This is fine. We're seeing infinity. MIP 2. I think we go up to 11 MIPs, so it'd be MIP 10. It's the highest. MIP 2 is fine. MIP 3. Right. MIP 4. I'm confused. Let's just skip the gun. Let's skip to 8. Oh, come on. MIP 8 is fine, apparently. MIP 9. 9's right. Apparently this is only like 2 pixels or whatever. And MIP 10. Like 1 pixel. What is going on then? Like, why are we seeing... What have I done which is incredibly dumb, basically? What have I done which is incredibly dumb that makes... So we clear the occlusion buffer to infinity or whatever, right? We render the occluders, but we don't because that's commented out. We upsample from the lowest MIP to the highest MIP, downsample. I could remove that code and see if it still bugs out. That's what we'll do next. So let's disable this. Then let's disable this propagate code. And we'll just see the cleared value now. Is it the synchronization code or something? Know what's happening there. That one's fine. So that's a different bug to fix. But this one here, we're seeing like stuff just blinking around. That's weird. Reading from MIP 5. Occlusion depth 0. These are all the ones that missed. Hey Jamega, how's it going? Hey Drenez, welcome. How you doing? It has been a while. So maybe it's not the propagate code. So they definitely had problems and we did fix them, but it's not the propagate code then. So I guess is occluded. Has still some problems. Is this this is meant to synchronize on it, right? And this clearly happens after. So, oh, for crying out loud. Oh, it's fine. Occlusion clear. Here we go. It's fine, that's fine. So, did we put, that's where I put the, where we're reading here. Let's check the sync code up here. That was read write, read write, read write. There's synchronization. But what about, let's view this in render doc because it'd be easier. It's something to do with the oh wait, where's the texture? You've moved since the last time. Oh wow. Did you move job or was it just you've found a better place to live, like cheaper rent or something like that? So this one will be 1 by 1 by 1, be a dims one. Right, so looking for like a where's a 2D dispatch? What is all of that? Right, there's the clear. And then followed by the occluder, the 1 by 1 by 1. Right, so here's the occlusion texture. Oh, for crying out loud, RenderDoc's not going to like me either. Apparently 8's buggered up. That's 8 apparently. That's 9. That's 10. I don't know if I can trust Renadoc though, because it's failed to tell me correctly in the past. But it's good to see that these ones are probably wrong. Oh, it could be wrong for some reason. Wait, it's correct after that. Okay, so it's correct after that. There we go. Okay, so apparently they're fine according to Renadoc. They're all cleared out. So occlusion. That clears fine. You've got infinity in there. You render the occluders next. Then this one. As an output. Then an input. In the clusters. What's that dispatch indirect? Why is it black here? This is if we went back in time. Undefined image. At this point it's undefined. So where's the pipeline barrier that messed this up? That is the case. Apartment 200 meters away from the old place. But with the dryer and washer, still need to pay for the previous one until the tenant one because the contract done it. That must be expensive. Hope that gets sorted out soon. I'm still struggling to get the basic lighting correctly. When I say basic, I mean just simple specularity. Specularity. Interesting. Yeah. Right, like the specular term. Yeah, I've not. It's been ages since I've done that myself. That's something I need to do still. Yeah, I'm sure I'll probably have similar things. But yeah, have you got any, what sort of project you working on, Meatball One? Shininess. Shiny. Have you got any sort of pictures you can share? Occlusion texture, here we go. Right. Old layout undefined. What is that? Why? What have you done? Is this a foundational problem why Renadoc has not been working for me sometimes? Maybe. And then AMD drivers are just like chugging along like, this is good. And I'm just providing it bogus information. Crying out loud, how long has this been wrong? Where's the general pipeline? Right, resource barrier. Right, before access mode. If it has right general. Right. This could be the reason why. So if it was read only before, it's gonna say undefined? What? What melon? What did I do? How has this been working the whole time? So you want it in general. I don't put anything else in general. See, stuff could be uploaded to as well, so you got to be really careful because you move it. Oh yeah, no, I move it into general, right? I move it into general layout. So I'll say if it was previously written to. Oh, but I do something in the GPU system where I say like, hey, this has been written to now when you do an upload, right? Let's find the upload code. So when we do the upload code, we say, hey, by the way, this thing has been written to. Where's that code? So I don't do that apparently. Because that will mean that puts it into right. What was the layout before? Turn it into transferred destination. Okay. Damn it. Okay, this thing is wrong. So I need to say if it's read or write. If it's got a read or write bit set, then it's general if not defined. Now, if you upload to it, I don't know where the uploads have been. Have I even got an upload texture? I don't think I do. It was as a test. Yes, I think those ones. If it then moves it into general, then as soon as I use it, it could fail. So I need to poke in the before access mode. I need to poke in there. Right, get the sync state for the resource. Where's the upload texture and buffer? So resource, we need to say, hey, we wrote to this. So we need to poke in there, write only. GPU accessor mode, write only. Boom. So I need to say that. Then I need to also do that in upload texture. And then upload manual, no. Cool. So I think that's been part of my issues is sync code. I did not expect my sync code would be wrong, but it is. Also, I'm at the stage with my current engine, so in between me gaming a lot at the moment, I've gone for to read a binary file, you first need to write a regex engine. The reason I want a DSL to define them, and while I do not need it, I'm going to write a parser lib and want it to support regex. Still slowly working on it and wrote a Unicode info library. Cool. This seems like many tunneling, many things you've gone down the rabbit hole with in that, actually. So why does your binary file need a regex engine? Are you defining the binary data structure in a custom DSL? Now, right now, I'm trying to get to the grips with C, not the language itself, but the style with which people write in C, which I was call idiomatic. Awesome. Good to know. Yeah, that's cool, man. Yeah, like, not many, especially people programming C++, they just get so used to programming with all the C++ features, and it's very easy to overcomplicate stuff. Right, so in the case you're wondering, the DSL would look like something like this, but with structures and just bogus example. Okay. I see what you're saying. Yeah, I've pondered this before, where you define and you may put variables in there as well. Excellent. Yeah, that's what I was thinking. Yeah, that's not a bad idea. Like basically, if you take a look at imhex, that hex debugger, they have their own DSL. Yeah, that's cool. This shouldn't be too bad to put together. Good idea. Good idea. 2 months down the line, custom DSL. Nah, probably won't be doing that, but it's definitely that sounds like a good idea. I'll probably just define mine in data structures and comments. Are you gonna make that a standalone library that's sort of independent from your engine, or what do you think about that? Wait. It's write only. It was write only before. Yeah. Really silly. Oh, do I need to clear the hang on a minute. I need to after access the mode. Maybe something like that, I think. It's a separate crate. Cool. Sounds good, man. Sounds great. Right, what's my problem now? Oh yeah, the sync code. I fixed it apparently, but also not at the same time. So if any of those are set, general. That's what it was before. What? Right, so it's 531. Somewhere about that one. Renadoc is like, hey, this works fine now. Wait, there's some holes there. Good. $539, kind of around there. Right. What is that? Draw 3D, but that's always there. Outputs occlusion texture. All this crap. I should name that compute pipeline. Then I wouldn't be having all these problems trying to decipher what shaders these are. I don't have the debug name stuff, do I? Object name, here it is. Kinda got it. I could do it. Where's those compute pipelines? Here we go. Alright, we have this naming utility. No, don't do this. Is there really not a... This is not the deprecated one, is it? No, it isn't. Good. Pipeline, there's a pipeline. Sweet. What am I naming? Oh, for crying out loud, I did the wrong one. Okay. So I'm naming shader name. Yeah, 256 ought to be good enough. And then we put in the object handle, which should be that one right there, the pipeline. And that should give me better debug info in here at least. Should read the shaded name down there now. Right, seeing some glitches there. Let's take this. Excellent. So we've got the shader name down here so we can actually figure out what we're looking at. So make persistent, way down here, let's go down. Right, prepare clusters at LOD. Right, occluded texture, occlusion texture. View the contents. Right, so as we go down now they're all here. What is that? Why is that an output? Is it because it's marked as read write? Why is it marked as read write? Is it because it's in the general layout, probably? Maybe because it's in general layout, but... Also had some fun with the NHS, but I'm finally officially on ADHD waiting list. Sadly about 12 to 18 months waiting. That's crazy. That's embarrassing. How is it that long? Like, sure. Can't you just go down to the doctor and the doctor, like, you would think, right? The doctor could just... Oh man. Yeah, I had nothing but bad experiences with doctors. Yeah. It's pretty crazy. You know, when you need an operation, the NHS is really great when you have the operation, get it done. But just the whole sort of way you get to get that operation is just such a bad experience. You have to kind of act like you're gonna die and also be really on the case to get things going at a good pace. It's kind of a shame. Yes, this cluster pair clusters, these boys. Right, we mark it as... Yeah, we saw this earlier, right? Read only. And then in this, it's read only, right? Crying out loud. Yeah, it's read only in here. And then we pull it out as read only. In the is occluded. Excuse me. Yeah, this is the only place where we've used it. It's read only, and we do a load. All right, so that's just a render doc thing. Probably seen it in the general layout. So that's okay. But anywho, we're able to look through the MIPS, and voila, they appear fine. Wait a minute. Can I take a look at that occupation map? I saw. It was not showing up in render doc correctly. I guess it's still not. I know I've lost the thing now. Why is it showing up black or transparent? Anyway, that one seems to be bugged. Right, let's view this occlusion texture again. Okay. Right, so there's the occlusion clear, 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 clear. Right, pair clusters. So here it's looking at all of those, that's fine. Go to the next one. That's set up in the indirect. That's all right as well. Let's keep going all the way down here. Right, so apparently all the pixels are fine now, supposedly. So we should be seeing correct pixels. But we're seeing some which obviously fail still. So if we take a look at the print output, we're getting 0 back. And we're sampling in range on MIP4, and it's like, hey, there's 0. Still. Is my number of MIPS? That's fine, yeah. We've looked into that. Are my texture views perhaps wrong? I can probably see those in render doc. Damn it, I can't see them in here. They're called texture view, they've not been named. Let's go and name those boys. Texture view init. Hey Kat, how's it going? Would you take an AI surgeon in the future? No. No way. Well, I've had the NHS take a massive hit these recent years. The process is also hell when you have ADHD and you had to go GP in the first place, arrange a call or arrange an appointment. So you had to get on the waiting list. Wallet is completely... Well, it completely makes sense why you would need to go through all the process. Right, okay. Yeah. I wish the system would improve. As well, like... Yeah. Anyway. I won't go into my issues I've had. Oh! Validation error. Right, wrong one. To trigger happy there. We need to do both. This should have been made into a function. But yeah. I should definitely make this into a function instead. This is increasing my LOC lines of code unnecessarily. Future me will solve it properly, I swear. Maybe I should call this a storage. And then sample. Right, so now I've got these boys here. We'll actually run this again in render doc. There's some glitches. Load that up. Man, there's too many of these things. Oh crap. Close the resource inspector. So we're looking for occlusion. Here they all are. So basically they are created. Base map of, yeah. The 4 and 1. Five and 1. We should have like 11 here, right? Two and 1. Three and 1. Guess that'd be 1 and 1. 6 and 1. These are all looking okay. Oh, 8 and 1. Nine and 1. What we can do is we can restrict the MIP to say 5 MIPs. And we can see how much of a problem it's having there. Where's that code? Is occluded. So why don't we just min it with 5 or something? Because it still go out of bounds. Oh no, because the ones that are having a problem, if I remember correctly, were still on MIP 4. MIP 4 and 3 were still having a problem. He's pulling out the wrong. What is that a float cast for? Why is it float casting it? That seems a bit suspicious. Still okay though. Still pulls out a 0. Every pixel is infinity. Let's see the other values then. Let's see it as a U32. That's another interesting value to see it as. Because it's stored as U32 for reasons. Right, so these have problems. Let's have a look at the... They're 0 apparently. when are those pixels set to 0? And if you take a look at render doc, they're not 0. So sampling in the bounds of the texture. I wonder what else could be the issue. It might be useful to know like which LOD this happens on. Basically like You were doing this for at least 2 years. No way. I started like nearly a year ago. So I've been doing like, yeah, so I've been doing it. I forgot when I started it now. I started in June 1st, I think, last year. That's somewhere, I forgot when I started, but it's nearly been a year, basically. I do 3 days a week, and I've taken a month off, and maybe a bit more, because I took a few weeks off for the baby, and then I had. I wonder if there's any sync code related problems again. It's not every day. What? Yeah, but how would it be 2 years if it's day 99? Good night, everyone. Best of luck, Hero and Jamega. Thank you so much, sir. Thank you. Yeah. Getting kind of late here, too. I'm going to inspect one more time in RenderDoc, I reckon. I just want to find out. I want to scan that texture again. Yeah, have a good night, Meatball One. Thank you for coming. It's good to see you again. Volume, prepare clusters, LOD. So, occlusion texture. What are we looking for? Prepare clusters at LOD. Yeah, so it uses this occlusion texture. It's got a barrier on the occlusion texture? Why? Why? Read. Old layout general. What? Storage read. Sampled read. What the crap is going on? It's not a sampled read. That's not good. Why is it putting barriers down? Oh, it puts the barriers down every time because I've got the profiling stuff on. So it always puts a barrier down. Right, okay. But anyway, why is it saying sampled read? That's not correct. Have I repeated that same mistake again? Occlusion, texture, what does that get made? So what is that? That is storage format, sample format. Okay, good. So storage formats. Okay, that's fine. what about the views? Right, they don't change the format. Sure. So, wait a minute, they don't change the format? It's just an alias. That's fine. So, yeah, why does it say sampled read in the back end? If it's texture sample read. No. That is not true at all. VK access mode 2. Oh, access flags. Let's view the enumeration. Right, it's a sampled read. Yeah, it's not for a sample image. Storage buffer or storage image. Yeah. That bad. So that is texture. That's only true. So this should be changed to is sample texture. It's a little bit. So how do we know if that is a sample texture? Resource texture dot sample format is not equal to GPU format none. Alright, so we need to do that in a few places where it says true. I guess we could have just given it the resource if we always have the resource available. So probably not too bad. But anyway, we've done that now. So that, I don't know if that's going to fix it. It's just correct though. Yeah, still got these issues. You can see the, yeah, you can see the clusters there, the 4x4, the kind of like voxelized there. These buggers, why are they doing that? But yeah, look at the render doc capture now. It should still show up, but it should be correct. So maybe I should disable the profiler thing that puts a barrier in between everything and just see if that is better. See if the barriers are more correct there. Yeah, now it's just doing a read, which is what we expect. So if I disable the profile mode, profiler, yeah, so we stop turning its profile individual shaders by putting a barrier in between everything. So now it's more like profile and everything. Wait, it's not profile until actually. But yeah, we're still seeing this sort of problem. It's just very strange to me why that's happening. Anywho, I'll have a think about what the problem is off stream and we'll figure it out. We'll debug it next time. But let's just recap what we've done today. So we've got the depth buffer from the previous frame, made that the occlusion buffer, and then we discovered that, hang on a minute. Wait. Then we plugged in the code which checks to see if a cluster is occluded. These things that are blinking, these clusters, they're a 4x4x4 set of spheres. And what happens is some of them were getting occluded, and it was strange what was happening. We just cleared the occlusion buffer to infinity. And now what's happened is the occlusion culling code is still culling clusters for some reason. So we've got to figure out why these clusters are being occluded still and not being rendered, even though they should be. And for some reason they're putting back a depth value of 0 when that should be infinity, and we've been checking the texture and it's filled with pixels with infinity. So it's weird. I don't know what's going on. Could be a sync code problem still. I don't know, but here's the occlusion texture. The value is this number here. I'm sure if you put that into hexadecimal, it would be a can I copy the value? Anyway, I'm sure it'll be a sure it'll be an infinity. Seems like it's got the high bit set. 1390954. Yeah, I wonder what that is. Float 32 infinity hex. There's multiple infinity values, but there's a constant. Right, that seems a bit off. It's not the same. I missed a 0. 0405909. Okay, good. So 7F8, right? 7 is 3 bits, so there's 1 4, okay. There's an F, all 4 on, and an 8. That's correct, that's infinity. So we're seeing infinity, we go over all the pixels, that value down there doesn't change. We go to 5 where it's having a problem with, going over all those pixels, all looks okay. Something weird's going on. It could be something to do with my compiler, I don't know what the issue is. Texture seems fine. Maybe something with a compiler. But I don't think so. I've done this sort of logic before many times. No idea. Okay, so let's find somebody to rate quick. So I'll next be on Thursday, 6:30 PM GMT +1. And we'll hopefully figure out that problem and get some occlusion texture stuff. Let's rate Tim. I haven't seen Tim on for a while. Doing some hands-on work. Awesome. Right. I'll see you all in a future stream. Have a good Wednesday and Thursday, guys. Thank you all for coming, and catch you later.